All right, 1.4, multiplying and dividing integers. So let's look at multiplication and what it is. Like, this is 3 times 9, right? So this is a pretty basic problem, which, we may be kind of used to. But what is this really communicating to us? Well, it would be the same as it saying we have, it's not really a question, it's just a statement. We have 3 groups of 9, right? So 3 groups of 9, that's great. How do we show that though? Well, you'd have a group of 9 right here. So you could even use counters on this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we need 3 of those, right? So there's one group of 9. Let's get ourselves another group. There's another group. And let's do another group. Whoa. Gotta use the right tool here. There we go. So 3 groups of 9, right? Well, how many counters is that? Well, if you counted them all, I'm not going to, but you could. You could see that it's 27. And this is important to remember, you guys. 3 groups of 9 is 27. Understanding that that's what multiplication is will be very crucial as we move forward in some of the other lessons, and even through 980 and 1010. Sometimes we forget exactly what multiplication is, but if we can remember what it represents, it makes a lot of problems in the future a lot easier. So the first number generally tells us how many groups of the second number we have. You could flip them though if you wanted to. Like if you wanted to say you had 9 groups of 3, that's fine. It may be a little bit more drawing if you wanted to use a model like this, but it's not required. And that would be the commutative property of multiplication, which I think we get into a little bit more. What is multiplication? It's really just simplified repeated addition, which we showed in section 0 of this unit, right? Like if you had, I can't remember what we used, like 7 plus 7 plus 7, right? Well, that's, if you had to write that down all the time where you're just repeating the 7s, you'd get pretty sick of it quick too. And this one, again, you just say you got 3 groups of 7, 3 times 7. Now, again, I don't use this vocabulary very much, except product. I do say product sometimes, okay? You got a multiplicand, which tells you the groups. The multiplication symbol would be like of some number of value or a multiplier, okay? I don't know if you guys play video games, but like a multiplier, right? It multiplies how many points you get for certain events or actions in a video game. It works the same way, right? So this is the number that you're multiplying, okay? Maybe that made it worse, I don't know. So let's start by, again, if we can get this down to what it actually is, then hopefully this will make sense. So this first problem, right? 5 times 2 is the same as 5 groups of 2. So we're going to have 2's, specifically 5 of them, which are being added together, because multiplication is just simplified addition. Well, one of the problems we run into is, well, what if we have groups of negatives, like we do in this case? This reads as 4 groups of negative 3. So I'm going to take this negative 3, and I'm going to write it in 4 times, right? Whoops. There we go. 1, 2, 3, 4. Now, again, it's repeated addition, so we are adding these together. Now, one thing we should notice, like 5 times 2, bam, we should know from our multiplication tables that that is 10. And I know this wasn't asking for the answers to these, but I'm more concerned with what types of answers they are. So I know 5 times 2 is positive, but if I look at the second part there, negative 3 plus negative 3 plus negative 3 plus negative 3, is my answer positive or negative? Well, I know it's negative because I'm just combining or adding a bunch of negatives together, so it's going to become more negative. If we can remember that this answer here is going to be negative, And if we can find out if an answer is positive or negative first, then we get to do the straight multiplication without worrying about the negatives. So 4 times 3 is 12. This answer would be negative 12. So on problems like these ones, we look at them, and again, the first thing I would want you guys to consider is if the answer is a negative or a positive. And the first one reads kind of weird. It would be like saying you got negative 3 groups of 5. But it's the same thing as 5 groups of negative 3. So if we wanted to know what the answer was on this one, we could know that it's negative. Now, I understand some of you guys at this point are thinking a negative times a positive is a negative. Great, okay? And it's true. A negative times a positive is a negative. Same with a positive times a negative. If you remember better that way, please do. But if you can remember it as multiplication, 5 groups of negative 3, I think you'll go a lot farther in mathematics. So if I know that the answer is a negative, that's great. 3 times 5, bam, is 15. So the answer there is negative 15. But what do we do about negative 8 groups of negative 6? Well, the negative from negative 8 tells us we're going to take the opposite of the negative 6, which makes it really 8 groups of 6. And the answer to that one is 48. Now again, just going back a ways, some of you guys are like, negative times a negative is a positive, which is true. And that works. We're going to look at this in a different way as well. Well, what if this third example, you got 7 groups of negative 4? Well, we did an example like that one, right? It'd be like adding negative 4 to itself a lot of times. So we know it's a negative answer. Then 7 times 4, which is 28. All right, here's a good problem. So to help us to understand what the rule is, which we're getting to, and I think we did kind of look at it a little bit before. Just look at these. Look at this problem and see if you can figure out the answer to it, okay? I'll give you guys a minute to look at this one and see if you can do it. 1 minute, go. All right, guys, hopefully that was enough time. If not, that's okay. It's almost not even necessarily supposed to be, but... and one of the problems with working through this from left to right, okay, is like negative times a negative is positive. Okay, that's good. Negative times a negative is positive, and then you'd rewrite it, okay? And that's great. However, if we look at this in terms of how many negatives are being multiplied, this is going to help us, okay? Because if I can figure out if the answer is positive or negative, then I can just multiply straight across. And there's a lot of ones. And when we multiply by 1, we get the same thing out of it. So, we'll figure out if the sign is positive or negative first. Now, I'm going to do that by counting how many negatives there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. Now, 9, just like we talked about before, is odd. There's an odd number of negatives. So I know my answer is a negative. Okay, if there were an even number of negatives, my answer would be a positive. So now that I know the sign of my answer, I can just multiply straight across. 1 times 4 is 4, times 1 is 4, times 1 is 4, times 1 is 4, still 4. Then multiply by 5. 4 times 5 is 20, and anything multiplied by 1 is itself, so it's still going to be 20. Negative 20. All right, now before we do the order of operations on this one, and yes, I would do the order of operations on this one, it just brings up a different question, is multiplying this, right? It's like saying I got 3 groups of 1 and 2. Now, really, that would mean that you'd have 3 groups of 3, right? Just by the order of operations. But if I were to show this in a diagram, not that you have to, but I'd have a group of, I guess, 1, 1 and 2. And I would need 3 of these. So we would just duplicate it 3 times there. 1, 2, 3. Now, the reason why this is important to notice is because eventually that 1 right there is going to be not a 1. It's going to be a letter. And that is where we get the property of distribution. I'm not going to go into too much detail on this right now, okay? But you guys probably have seen these distributive rainbows. It's a double rainbow, which has caused grown adults to cry and their videos to go viral, but maybe that's an outdated reference too. So you're going to end up seeing stuff like this, and this is shown in a very different way. Again, I'm not going to go into too much detail on this. It's just saying that you have 3 groups of some value and 2. And eventually it'll equal something, but since we don't know what the x is, it would kind of be a different shape, right? But you'd have 3 groups of the x and 3 groups of the 2, which means that you'd have 3 x's and 3 2's, which value is 6. Okay, and again, that's leading into distribution, which is shown with this as the property. And again, you're taking the number on the outside of the parentheses and multiplying it by the first number and the second number. So a times b, keep the sign plus, and then you do a times c right there, and you'd add those 2 values. Now this is abstract, so we're using letters. But in the homework, these are going to be numbers, right? Like a would be 5, b would be a 6, and c is a 7, something like that. And this is the general rule for multiplying with negatives. So again, it's three parts, 2 questions. The third one gives you the answer on if the answer is positive or negative. The multiplying, we hope for you guys, is pretty easy to do right now, okay? So the first question, how many negatives are there? Just like we did in that example before. Number 2, is that value even or odd? In the previous example, we counted 9 negatives. 9 is odd. So right here at the end, we know, since there were an odd number of negatives, the answer was a negative. After that, I ignore all the negatives in the operations. I know my answer is a negative. But again, if there were an even number of negatives, then your answer is a positive. So for a problem like this one, the first thing I would do, again, is just to consider how many negatives there are. So right now, I start with 1, 2, 3 negatives. Now 3 is odd, so I know my answer is a negative. Again, now when I do the multiplication, I'm just ignoring all the negatives. And I'm doing 5 times 5 first, which is 25. That's these 2. And then the new expression, right, times the 6. Again, I'm not worried about the 6 being negative because I know my answer is negative. And 25 times 6. So we'll use long multiplication for this. 6 times 5 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15. So I get 150 out of that. Now again, the 150 is not the answer because I need that negative tacked onto it as a negative 150. All right, so here's another problem like the one we did. So again, we're going to go through, we're going to count how many negatives there are. 1, 2, 3, 4, 5, 6, 7, 8. Now this example has 8 negatives. 8 is even, so we know the answer is a positive. So I'm just going to put the positive sign right there so I don't forget that the answer is positive. Now 1 multiplied by 1's not going to matter. I can even just cross these out if I wanted to. So I'm really just looking at whatever 2 times 10 is, which is 20. Positive 20, which is the final answer on this problem. All right, negative bases and exponents. So we talked about exponents, but when the base itself is negative, right? The base is this number that is being multiplied by itself. The exponent tells us how many times it's being multiplied by itself. But the way these are written will determine if the answer is positive or negative. So this first question, right? What are the differences between the following Well, the difference is how many negatives there are. If you see this first example, okay, and when we start using calculators, this is going to be crucial on whether you use parentheses or not. And it should show us depending on how it's written. So we'll see those in examples later on. But this first example, I know it's negative 2 to the power 4, but how many negatives are there? There's really only this one negative, okay? And that's because the base is positive 2. The negative really is kind of on the outside of that exponential expression right now. So it's really negative 2 times 2 times 2 times 2. Now, since there's only one negative, we know the answer is a negative. It would be 16, negative 16. So what about this next problem, though? Well, how many negatives are being multiplied on this one? With the negative in the parentheses for the base, that tells me I got 4 negatives. If I were to expand this, it would show as negative 2 times negative 2 times negative 2 times negative 2. So see how that's 4 negatives being multiplied? 4 is even, so I know my answer is positive. And 2 times 2 times 2 times 2 is 16. Now this next one, hopefully there isn't a lot of explanation necessary for this one. This would show as negative and then 2 to the power of 4. This one matches the first one that we did there in purple and red. It's just showing the multiplication in a different way. So in this multiplication problem, we see only one negative, so the answer is a negative. And 2 times 2 times 2 times 2 is still 16. It is crucial that you guys understand the difference between these three. Particularly the top two, you're going to see these written this way in the homework, and you have to know the difference between the two, okay? All right, let's go to division. So division is like splitting a certain value into equally, or you're splitting it equally amongst a set, okay? So how many times a value goes into another, or how many groups of a number are in another number. This is 4 different ways that we see division. Okay, so we have long division right here, which we're going to see in the first 2 modules because you can't use calculators yet. You'll see this, but we're going to work more with long division. Unless it's something very basic, like since we should know our multiplication tables up to 12s, we should understand divisions also in the same way. Now, in a division problem, you got a dividend, a divisor, and a quotient. I do use this vocabulary more often than the others, like the addend and the multiplier stuff, okay? I will say dividend, divisor, and quotient quite often so that we understand which part of the division problem we're using, because where values fall in a division problem is pretty crucial, all right, with where it goes, especially in terms of long division. Because with a long division problem like this, that may not have been drawn very well, but the dividend, the first number, that goes inside of this division sign. So that's our dividend. There we go. And the divisor is the number on the outside there. So in this problem that they gave us, 5 and 10, so this would read as 10 divided by 5. 10 is the dividend, 5 is the divisor. So we need to remember that when we're writing long division, that we don't get these mixed up. So again, we're not, I mean, some of you guys could solve this, right? Pretty quick, because we should know our division or multiplication tables. 7 times 8 is 56. So 56, if we split it up into 8 equal groups, is 7. And that really is the question is, if I split 56 up into 8 equal groups, let me make that a little bit bigger. Let's write that in. If we split 56 into 8 equal groups, how much will each group get? And yeah, my grammar may not be very good on that, but hopefully that makes sense. Oh, I spelled.
Grammar's fine, just the spelling.
I was so close, man. Equal. There we go. I don't really have autocorrect on this, but there we go. I did mention I said 7 times 8, right? That's because that creates a fact family, which means that 56 divided by 8 equals 7 is the same as 56 equals 8 times 7. Now, the reason I'm showing this to you guys is because when we start getting into division, I mean, you guys saw I made a mistake in that one section. It's common for us to make mistakes, especially when we're doing stuff in our heads. But there's ways to check things like this, right? If you wanted to know if 56 divided by 8 is 7, just take the 8 and 7, multiply it, and see if you get 56. And that's why I said, if you guys have your multiplication tables down, the division becomes pretty simple. So the division on this one, before we get into the dividing these, I'm just going to write it the several different ways, just so we understand the difference, right? So like on a calculator, it would maybe show with the slash, right? Negative 20 divided by negative 4. Regular division would show 20 divided by negative 4. As a fraction, the 20 is the numerator, negative 4 is the denominator. We'll get into more into that in a different module. But like I said, if we were to do this with long division, and, well, we'll address the negative thing here in a second. So, long division, right? So I got 20 divided by negative 4. Now, division works the same way as multiplication. If you got an odd number of negatives, the answer is a negative. If you have an even number of negatives in a division problem, the answer is a positive. Now, in this case, it's odd, so I know my answer is negative, so I don't really need to worry about the 4 being negative anymore, as long as I know my answer is a negative. Now, just a quick review on long division. I take my value 4 here, and I start with the place value farthest to the left, which is this 2. That's the tens place. 2 is too small to split up into 4 separate parts. Yes, if you want to use decimals, that's fine later on. But for now, I'm just going to move over another place value into the ones and show this as 20. 4 does go into 20. In fact, it goes into 20 evenly 5 times. Now, going back to long division, just to check this and to figure out remainders, you do 5 times 4, which is 20. And since that 20 has been used up with the 5, we're going to subtract it from the value we started with, which is 20. So I have a remainder. The R is a remainder of 0. And my final answer there is negative 5. Now, you could have said, well, I know my fact family on this one, Sal. Okay, 20 divided by negative 4 is 5 because, negative 5. Because negative 4 times negative 5 is 20. And I remember that because I know my multiplication tables. That's great, okay? Again, I'm just showing long division because it's a very common method to use, especially when we're not using calculators like we are in this section. So again, dividing with negatives, if you have an even number of negatives, which it shows right here, the answer is a positive. And if you had an odd number of negatives, like it shows in these two examples, your answer is a negative. You could still look at it like this, right? Like positive divided by positive is positive. It just seems like that's 4 different rules, whereas you could separate it into 2 separate rules, like we do if there's an even or odd number of negatives. But it's up to you guys. Now, multiplication tables, right? Like this one, negative 595 divided by negative 7. Look, if you know your 7 multiplication tables up to 595, dude, you are awesome. Okay, I am not that good. So, for me, I am going to need long division. But before I go into long division, I am going to figure out if my answer is a positive or a negative. In this case, we have two negatives. 2 is even. So my answer is a positive. Now we'll do the long division. 595 divided by 7. Now again, 7 won't go into this 5, so I mean if you wanted to hold that place value as a 0, that's fine. 7 will not go into 5, but it will go into 59, which now I'm looking at the tens place value, and I'm going to place that value above the tens place value. This will be crucial later when we get into decimals. Now, again, I'm looking at 7. How many times does 7 go into 59? We've already seen that it goes into 56 8 times. Now, when I multiply this, I'm going to do 8 times 7, which is 56. Again, I'm going to subtract it. If I subtract and my remainder is bigger than my divisor, which in this case is 7, then I didn't have enough. Like, the 8 would have to be adjusted. So I would have to erase this stuff, and I'd have to go back and adjust this number. In this case, it's less than 7, or the divisor, so I can just keep it there, okay? Now, again, 3 is too small for 7 to go into, but if I go to the next place value, the ones place, and I drop that 5 and make this, because the 3 was in the tens place, so it's 30. If I take the 5 and add it onto it, I get 35 here. So, how many times does 7 go into 35? Bam, 5 times. 5 times 7 is 35. And some of you guys know right now, since we're dealing with integers, there shouldn't be remainders right now, if I remember right, okay? So with a remainder of 0, there shouldn't be any remainders. My answer is 85, positive. All right. Now again, we should only know our multiplication tables up to about 12. I'm not very good with my 35 multiplication tables. That's okay. I'll show you guys how I do this problem, and then you can, I guess, determine if you like it or not. But for me, again, first I would just figure out if the answer is positive or negative. I see this 1 negative. 1 is odd, so I know my answer is a negative. Now I don't worry about the negative. I'm just going to write it out. 9,380 divided by 35. Now, because I don't know my 35 multiplication tables very well, I'm going to list the multiples of 35 to the right here in green. I do know my first multiple of 35 is 35. That's an easy one. But if I wanted my second multiple, what would I do? I would add 35 to it. So I'd say plus 35, and what do I get? Bam, 70. So there's my first multiple, there's my second multiple, 70. Now the third multiple, I would just add 35, and I would continue this pattern until I have at least a few, probably at least the first 5 multiples of 35. So there's my first 5 multiples. I'll just list them again. We got 35, 70, 105, 140, and 175. And if I need more, I will. I'll tack those on, but let's see if that takes us far enough. So for this problem, I got 35, which will not go into 9. I can put a 0 there to hold its place value in the thousands. What about 93? Well, 93 looks like it's less than the 105 here, but more than the 170. So the 70 should work as the second multiple. And again, I don't need to think about what 2 times 35 is because I have it listed right here as 70. So I'm going to subtract that 70 right there. Bam, I get 23. Now 23 is less than 35. That's what I wanted. So I'm going to drop the tens place value as 8. So how many times does 35 go into 238? So it looks like I do need the 6th multiple, maybe even more. So plus another 35 makes that 210 right there. And if I add another 210, I just ran out of space, plus another 35 would make that 245. So that would be the 7th multiple. 238, which is less than 245 but more than 210, means that we're looking at the sixth multiple there. So 6 times 35 is 210. Again, we'll subtract that, and we get, there's an 8, 2. 28, which again is less than 35. We'll drop the 0, make that 280. So we don't have anything big enough yet. If I add another 35 there, I get 280. So what multiple was that? That's 1, 2, 3, 4, 5, 6, 7. It's the 8th multiple. There we go. The 8th multiple, which was exactly 280. No remainder, just like we wouldn't expect in this module yet. And my final answer, I still need that negative up here. I'm going to have to get more space. So negative 268, my final answer. Now that was a lot of work. Some of it was taxing. Some of it was awesome. I don't know which parts, but hopefully you found some of it at least useful. Now again, when we get to the calculators, I would just type this into a calculator and be done. All right, let's go ahead and divide this problem up. We got 1,690 divided by negative 67. And just to start off, I can see that I have an odd number of negatives, so my answer is a negative. It's a good thing to get out of the way. And to write this out with long division, I take the 1,690 and divide it by 67. Okay, now I am not familiar with my multiplication tables with 67. So I'm going to need to make my own, all right? So I got 67, that's my first multiple. And if I had another 67, that will give me my second multiple, which is 134. Add another 67. So again, I'm just adding 67 to each of the previous sums to figure out the next multiple of 67. And you only ever need the first 9 multiples. After that, you shouldn't need any more because we're going through these values one place value at a time. So you should never have a 2-digit value from these. So I'm going to go through this problem, right? I see 67 does not go into 1. It does not go into 16, but it will go into 169. Looks like that's my second multiple, the 134. So we'll say it goes into it 2 times. And 2 times 67, again, I'm using my chart there, 134, so I'll subtract that. So 9 minus 4 is 5, 6 minus 3 is 3. So 35 is less than 67, that's what we want. I'm going to drop it down to make it 350. And at this point, 67 goes into 350. That looks like it's this multiple. That's the 5th multiple. 5 times 67 is 335. So when I subtract these, I get, that'll make that a 10. 4 minus 3 is 1. That's 15. Now, we're not worried about decimals right now. So this is my remainder. I didn't really expect to see a remainder this early in the semester. But the final answer here would be, again, we got the negative 25, but with a remainder of 15. And I would probably include that in my answer. It seems like there may have been a question like this on the homework. So keep that in mind, you guys, while you're doing this type of problem. But dividing with 0, we'll go over this. Remember what division is asking. How many times does a value go into another? So if we can remember what division is, then solving these types of problems generally becomes a little bit more understandable, kind of. Like 0 divided by 8 would say how many 8s are in 0. Or if I split 0 up into 8 equal groups, let me think if I'm saying that right. If I split, let me think, make sure I'm doing that right. If I split 0 up into 8 equal groups, how much would each group get? 0. They would get 0, right? Now the second part, 35 divided by 0. So how many zeros are in 35? Or if you split 35 into 0 equal groups, how much would each group get? Well, the truth is, since you're not splitting it up at all, they get as much as they want, which means that it goes up to infinity. In fact, let's look at this as just a straight division problem, right? 35 divided by zeros. 0. How many zeros are there in 35? 1, 2, 3, even more, right? It goes up forever, and it's still going up even right now because it's so big. It's what we call an undefined value because it is infinity. Infinity is such a big number that, as far as we know, even in the world of academics, there is only one human being that is counted to infinity.
Chuck Norris.
That is correct. Chuck Norris counted to infinity not once, but twice. So, just with some word problems and that division and multiplication stuff, a student hears a weather report saying that temperatures will be decreasing approximately 6 degrees every hour for the next 5 hours. What signed number represents the total change in temperature expected over the next 5 hours? Well, in this problem, since it's decreasing 6 degrees, that's going to be a negative 6. Now, in this case, it's doing this every hour for the next 5 hours. That means we'd have 5 groups of this negative 6. Now, if you wanted to, you could show the addition. Negative 6 plus negative 6. It's a lot of writing, right? See how this is already becoming quite tedious and slightly painful. I just wrote that, and that sucked. But when I wrote the 5 times negative 6, I loved it. Well, not loved, but I liked it. So I got 5 groups of negative 6. I got an odd number of negatives, so my answer is a negative. 5 times 6 is 30. Now, keep in mind that if we were to write answers in like on a piece of paper, if you wrote negative 30 like this, the answer would lose 1 point. And the reason that is because this is a word problem. So even though negative 30 is the signed number, let's label it as negative 30 degrees. That would be a better final answer.